Today we're going to talk about solving linear quadratic systems. Way back in chapter 4 we talked about solving linear systems by looking at different methods of how we can do that. Remember, we talked about how we solve systems by graphing, by substitution, and elimination. When we worked on this way back in chapter 4, the two lines that we'd be using were both linear equations, and now we want to talk about how do we find a solution to a system that has one linear equation and one quadratic. So we're going to show you the three different ways, basically. Well, actually not the three different ways, because I'm not going to show you the graphing way, but basically if you were to graph your two equations, you'd be looking for the intersection points. So we know that the intersection point would be the point that is shared in both equations, one linear and one quadratic. So we're now going to show you, though, the next example, for example 1, how to solve using substitution. Well, we have both of these equations already solved for y. So because y equals these two right-handed sides, we can basically kind of create one merged equation, setting them equal to each other. Now, once we have them set equal to each other, we want to think about moving all our variables to the same side. And notice how I'm going to line these up to make sure that my like terms are going only with my like terms. So I get x squared plus 3x minus 1. And then I'm going to continue to bring the 3 over here with a subtracting 3 to get 0 equals x squared plus 3x minus 4. Now, earlier in this section we looked at several different ways of how to solve a quadratic, and I think when I look at this one, my first thought on all of these is to see if I can factor. And if I look at this one, I can see that I can do something with my factoring. So because I can factor this one, I am going to go ahead and factor. I'm going to set up my two binomial double bubble parentheses. I'm going to put x on the fronts. And if I think about my factor pairs of the negative 4, I'm going to use 4 and a 1. And because I'm trying to combine to make a plus 3, I'm going to keep the 4 with the positive and the negative with the 1. So now through my zero product property, if one of these expressions is equal to 0, then it is successful. So this is where we then use both binomials separately and set them equal to 0 to find what the x value is. In this one I'm going to subtract 4, so x's are negative 4, and in here I'm going to add 1 to both sides to get x equals 1. So the points where these two are going to intersect, or to solve the system by substitution, is going to be when x's equals negative 4 and 1. But so remember, these are just our x values. When we find our system solutions, we need to plug back both of those two answers back into our original equation. So really what I want to do is I want to pick one of the equations to put them back in. Well, I think we should all agree that the y equals negative 2x plus 3 should be a little more of an easy one to plug in. So I'm first going to plug in negative 2 times the negative 4 plus 3. Negative 2 times negative 4 is 8, plus 3 is 11. So one of my solutions is negative 4, comma 11. And then when I look at the same equation again, this time I'm going to plug in y equals negative 2x plus 3. This time I'm going to get negative 2 plus 3, y equals 1, which means that 1, 1 is another solution to this system. So let's look at the second one. So again, the second one, though, we're going to try to do this one by elimination. So when I think about elimination, remember we talked about how we want to eliminate one of the variables so that we could solve for the other one. So I think what we want to think about here is if I take this first equation and keep the y's the way they were, and think about multiplying the second equation by my -1 out in the front, what we're going to create is the following. The first equation is going to stay the same, but what we're going to create is in the second equation, minus y comes from the negative times the y. We're going to get equals negative 3x is a plus 3x, and the negative 8 becomes a positive 8. So all of a sudden we're going to start seeing a few things cancel. We see y minus y equals 0. X squared is going to stay. We see negative 3x plus 3x is going to cancel, and then we're going to have negative 2 and 8 is a plus 6. Well, now at this form I can see right away that I want to use my square roots. This is now very easy to look at as a simple two-step algebraic expression by just simply saying subtract 6 from both sides. I don't want to think about factoring, I don't want to think about graphing, because right away here is my x squared equals negative 6, which we talked about in the last few sections. X squared equals d would help tell us how many what our answers are pretty quickly when you have all the x's in one term. I would take the square root of both sides, and hopefully we notice right away I can't take the square root of a negative number like a negative 6. So the problem we have is I get x for the right hand side, but I cannot take the square root of a negative and get a real number. So our answer is no real solution. And what that basically means is if I was to graph this, and I was to try to solve this with graphing, I would have a graph where neither of them touch each other and have any intersection points, and that's where we would have the no real solution. In our next example, we are asked to look at the different statements about the system and basically determine which one is valid. We can certainly look at those answers, but I think one of the ways to just kind of tackle some of these things is to kind of just figure out what is our solution, and then we can kind of look at our answers from that point. So looking at these, I would probably just go with our substitution method, because again I think that when you see y equals and y equals, in some ways that might be the easiest way to just jump right in and start solving. Especially for some of us that don't want to graph, it kind of gives us a quick, easy start using your algebraic steps so that we can kind of get going quickly on this and start seeing what we have to deal with as far as adding and subtracting and getting down to x equals and then looking at what we have. So here we go, we have the x minus 3 on one side. So I'm going to first bring the x over by subtracting x. That's going to give me a negative 3. I'm then going to add 3 to both sides. And I get my 0 on one side, 2x squared plus 4x plus 2. And again, now I want to take a step back and say, well, can I factor this? Well, first of all, the very first thing we've always said you want to look for is a greatest common factor. And in this case, we definitely have one of those. So I want to take out the 2's to get x squared plus 2x plus 1. Then when I go to divide by 2 on both sides, I then create the 0 equals x squared plus 2x plus 1. And again, we want to start recognizing the perfect square trinomials. If I look at this x squared plus 2x plus 1 equals 0, I should be able to recognize that I basically get x plus 1 times x plus 1, which is the same thing as x plus 1 squared equals 0. So when I use my zero product property, I basically don't have to do both of them because they're both the same thing. I end up with x equals negative 1. So again, if I was finding everything about this, this is not just the only part of my answer. I need to go a little bit further here to find the system answer. I need to take one of the equations, and for sure the x minus 3 one is the easiest, most simple to figure out. I'm going to plug in my negative 1 minus 3, so y equals negative 4. So the solution is going to be at negative 1, negative 4. Now, when I start looking at all the answers up above here, that's not even one of the answers, so it doesn't really give me a whole lot of help here. Although in some ways it does, because it tells me I only have the one answer to deal with. So I want to start looking through all my possible choices. So when I first look at the question for what is this, what is the statement telling us about the systems and which one is valid, I want to go through each one. So for letter A, there was one solution because the graph of y equals x minus 3 has one y-intercept. Well, we know that's true. It does only have one y-intercept, but we're talking about a system. This is talking about the one graph. It's not talking about both graphs, so I'm going to kind of cross that one out. The second one says there is one solution because y equals x minus 3 has 1, 0. Well, that's actually going to be true also, because we know it's only going to cross over the x-axis once, but again, it's still only referring to one equation. We're talking about two equations as a system. Letter C seems promising because it says there's one solution because the graphs, and notice graphs, of y equals 2x squared plus 5x minus 1 and y equals x minus 3 intersect at one point. Well, we've already proven that that is true for sure. And then just to kind of verify we do have the right answer, if I look at the bottom one, there are two solutions because the graph of y equals 2x squared plus 5x minus 1 has 2x intercepts. Well, we never even found that that actually is true or not. I don't think it is true, but even if it is true, it doesn't really matter because of the fact that they don't intersect in 2 points. We just verify that they only have one solution because they intersect in 1 point. So there are not two solutions. That would tell me that C is definitely your answer. So that is how you would answer that question.